Good evening, everyone. Are you all able to hear me? Am I audible?
Yes, ma'am.
Okay, thank you. Okay, I think let us start the session. So today it is the week 7 of the Introduction to Abstract and Linear Algebra. So we will solve some problem related to the week 7 content. Okay. So let me first share the screen. Is my screen visible for everyone? Is the screen visible? Excuse me, is this visible? Okay, so let us start the session. So in any case, if you face any difficulty like with my voice or screen, please just let me know through through the chat, or you can just unmute yourself and talk. And if you have any doubt also, you can ask in between. Okay. So first we will go through the concept that covered in the last week. So let's just go through the concept without going to the proof and all. So for the proof and all the details, go through the lectures if you have not gone through it yet. So the last week started with the matrix, the rank of the matrix. Rank of a matrix. Okay. So what is the rank of a matrix? Can anyone say? If we have a matrix A, what is the rank of a matrix? So let me give the definition. So a number R, if A is any matrix M by N matrix, and a number R is said to be the rank of the matrix if there exists a minor of order R. By a minor, you can just see a kind of submatrix. Submatrix, not exactly submatrix, a matrix that can be extracted from the given matrix A, which is having an order R, that is R by R square matrix. So, if such a matrix existed with the determinant non-zero, then and also this R is the maximum value such that the determinant is non-zero. That means for R plus 1, R plus 2, and so on. So the determinant of such a matrix with order R plus 1, R plus 2, and so on. So if the determinant is 0, then in that case, we say this R is the rank of the matrix. Okay. Just one or two example we will quickly see. So I'm giving the matrix A and another matrix B. So can anyone say what is the rank of A here? Can anyone say what is the rank of A? If you don't understand the concept also, please let me know. Otherwise, if you understand the concept, please answer the questions. Did all of you understand what is rank? If the answer is no, please tell no. And if you are understanding, just let me know. Sorry, if you are not responding, I cannot go like this. I need some kind of response. Like if you are not understanding also, it's fine. Please respond at least. Snega, can you just tell what is the rank of A? Are you all able to hear me? Okay, if you're not talking, let me proceed. Okay, as I told, if like any voice problem is there from my side or your side, please let me know through at least the chat. Okay, let's see. Here, the matrix A is given as 1, 1, 0, 0. So the rank is the subsquare. subsquare which is having determinant non-zero. So what is the determinant of A here? Here determinant of A is 1 into 0 minus 1 into 0. That is 0. Okay. So here the rank cannot be 2. Okay. The possibilities for rank of A is either it is 2 or it is 1 or it is 0. Rank cannot exceed the order of the matrix. Okay. Here the order of matrix is 2 by 2. So rank cannot exceed 2. Okay. If determinant of A itself is a square matrix. If determinant of A equal to 0, then rank is not 2. Okay, that is what definition says. First, it says at least one minor of at least one minor of order R with the determinant non-zero existed. One case, if R is a rank, one case is this one. Okay, here this implies rank is not 2. That means if rank is 2, there should exist a minor of A whose determinant is 0. It is not possible because the possible minor of order 2 is having determinant 0. So the next case is rank is 1. Okay. Here we can see there exists the submatrix 1 of A I am taking. Okay. And determinant of this submatrix is 1 itself. Okay. This implies rank equals 1. So we got an order 1 minor such that whose determinant is 1. And there exists no order 2 minor which is having determinant non-zero. Okay. So here the rank of A is 1. And what about the rank of B? Can anyone say? Okay. Can anyone say what is the determinant of B?
-5.
Yeah. Determinant is 1 minus 6 equal to -5, which is not equal to 0. Okay. Since the maximum possible rank is 2 here, so the minor of order 2, say 1, 3, 2, 1 exists with the determinant non-zero. Okay. So we can say rank of B equal to 2. Clear? In this way, for any matrix, we can see rank. Okay, we will find the different ways of finding rank. Okay, this is the basic definition of rank. Other than that, we have so many ways to find the rank of a matrix. So we will go to it later. Now, one note here is rank of A less than or equals minimum m n, where A is an m by n matrix. Okay, so what it says is for any m by n matrix A, the rank of A will be less than or equal to minimum of m and n, minimum of number of rows and number of columns. Now, the next thing covered in the class is just the basic properties of matrix and all. In that one thing, I will just state the result. If A is invertible, that is if determinant of A is non-zero, then A inverse is adjoint of A by determinant of A. Now the elementary operations. So we have some elementary operations in matrix. If we are getting a matrix A, we can change the matrix like just by adding the rows or interchanging the rows. Some operations we can do. So what are all the possible elementary operations? The first one is the ith row and the jth row are interchanging. So 1 and 2 interchanging means in the place of first row 2 is coming, in the place of second row first row is coming. So that is mean by Ri and Rj interchanging. Okay. And second one is the scalar multiplication of particular row. If Ri is a row, then we can change the Ri to Cri. That means each element in the row is multiplied with the scalar C, where C is a non-zero scalar. Okay. So this is the second possible elementary operation. And the third operation is Rj. The jth row Rj is changing to Ri plus alpha Rj. What it actually means is just the sum of two rows. Means Rj, first we will multiply with the scalar alpha, alpha Rj, plus the Rith row we are adding. So this is the another elementary operation. So the special thing about this elementary operation is if we have A is an M by N matrix. Suppose we are having. And we are doing some kind of operations. A is an M by N matrix. And we are doing some kind of operations like this. And what we will obtain is B. After some elementary operations. Okay. So after doing some elementary operation, we can make this A into a simple form. Okay. Call it as B. Okay. After any element operation, whatever we are getting, we call it B. So in this case, what we will say is, we have a result, rank of A equals rank of B. Okay. This is the importance of this elementary operation. If we are having some kind of complicated in the sense, like everywhere some entries are there and all. So we can reduce it into some simpler matrix B and we can find the rank of B, and then this rank of A and rank of B will be equal. Okay. Now, we know the system of equations. Okay. So, usually any system of equation, we can write it as Ax equal to B, where A will be a matrix, M by N matrix. A is an M by N matrix and X will be an N by 1 column. Okay. And M by N by 1, what we obtain is M by 1 column B. Okay. So if we have this is actually a system of linear equation. We are writing in a matrix form. So how we can write it in the matrix form? We will come through the questions. Okay. If such a matrix form Ax equal to B is there, then if it has a solution, then we call it is consistent system. And if it has no solution, then it is inconsistent. Okay. Now we will see in which cases it will have a solution and in which cases it will not be having a solution. Okay. Suppose A is invertible. Okay. Now, does there exist a solution for this system? Can anyone guess? Given A is invertible. What will happen if I multiply? A is invertible, so A inverse exists, right? So what will happen if I multiply the system with A inverse on both sides? What we will get is A inverse AX equals A inverse B. Okay. What is A inverse AX? It is X, right? X equal to A inverse B. So, this system has a solution. Has a solution means there exists some value for the variable X such that it satisfies X equal to B. Here, if we are taking X equal to A inverse B, so put this value A inverse B back to the system. A into A inverse B. What is this? A into A inverse B equal to B, right? So, this system is consistent because solution existed, right? Okay. So, I will generally say like in which case solution exists, in which case it does not exist. So here actually one thing is if rank of A and rank of AB. What does this AB means? A1 slash B. This means the matrix A and the column B also we are just adjoining on the side of A and finding the rank of the matrix. We are not doing any operation, just placing the B just near the A and finding the rank of the matrix. And this matrix is called the augmented matrix. If this rank of A and rank of AB are equal, then solution exists. And if the ranks are not equal, then there does not exist any solution. Okay. Now, in the first case, we can ask the question whether the existing solution is unique or not. Okay. Now, if rank of A equals rank of AB and which is equals number of variables. Okay, number of variables means X is a column, X1, X2, etc., Xn, something will be like that. So, the number of rows of the X, okay, that is the number of variables. So, if rank of A equal to rank of AB equals number of variables, then solution is unique. Okay. Now, the next case is if rank of A equals and rank of AB which is strictly less than number of variables, we have infinitely many solutions. Okay, so these are the two cases. First of all, the rank of A and rank of AB should be equal. And if it is equals number of variables, then solution is unique. If it is strictly less than number of variables, infinitely many solution will exist. Okay, so yeah. Now after that, we have gone through row rank and column rank. So given A is an M by N matrix, and what is row rank of A and what is column rank of A? Anyone knows what is row rank and what is column rank? Here, row rank means, okay, let me first state this dimension of R of A and dimension of C of A. Now, what does this R of A and C of A means? R of A is the linear span of rows of A, and C of A means linear span of columns of A. Okay, so if we have a matrix A, we have rows and columns, right? So we will take the rows and take the all the linear combination of that rows. So whatever we are getting, it is a vector space. So a vector space generated by all the rows. So we are taking the dimension of that vector space. Okay, dimension of R of A. That is the row rank. In the same way, we will take all the linear combination of columns and we will get a space C of A. And the dimension of that space is called the column rank of A. Okay, is that clear? And okay, now let's go through some results related to this rank, row rank, column rank. Okay. So these are something important. You just need to remember this basic result. So A is an M by N matrix we are taking. If A is an M by N matrix, row rank will be less than or equal to M. Can anyone say the reason why row rank will be less than or equal to M? Can anyone say what is the reason for row rank is less than or equal to M? Because from the definition, we know that A is an M by N matrix. So A has M rows. Okay. And row rank is the dimension of the vector space generated by these M rows. That means we are taking all the linear combination of these M rows to obtain the vector space. So obviously, the basis of this vector space will have less than M elements because these M rows generate the vector space. Okay, but maybe some M minus 1 rows out of this can also generate the vector space. These M rows are just some rows which generate the vector space. So a lesser number can also generate the same vector space. Okay. That is why row rank is the maximum possibility of row rank is m. In the same way, what will be the maximum possibility of column rank? What should I write here? Column rank will be less than or equal to?
Madam, n?
N. Because we have n columns there. So this n columns, the linear combination of n columns gives a vector space, and the dimension of that vector space is column rank. Okay. Obviously, in some case, the lesser number of less than n elements can also generate the same vector space. Okay. So that is why the column rank is less than or equal to n. Now, so even though we are writing row rank, column rank, everything, one of the important result here to note is actually this row rank. Whatever the matrix A we are taking, this row rank and column rank will be equal. And it will be equals to the rank of matrix A. So the rank of the matrix A, we have already defined what it is. Okay. So this column rank will be equal to row rank, which will be equal to rank of A. So in order to find the rank of A, it is enough to find the row rank or column rank. Now the next important result is okay. Rank of AB. AB means the product of A and B. It will be less than or equal to rank of A, and it will be less than or equal to rank of B. So in general, we can say the rank of AB will be less than or equal to minimum of rank of A and rank of B. And one more result, rank of A plus B will be less than or equal to rank A plus rank B. Okay. Rank of A plus will be less than or equals rank of A plus rank of B. Now, in the last lecture of the last week, what we have studied is the characteristic polynomial and the characteristic equation. Okay, do you remember what is the characteristic equation of A? A is a matrix. A is a square matrix. What will be the characteristic equation of A? It will be determinant of A minus xi equals 0. So, we will have a matrix A, square matrix. Suppose A is an n by n square matrix. We will consider the n by n identity matrix. Okay. And multiply that with the x. So, we will get an n by n matrix with the diagonal element x. Okay. Then we will do A minus xi. X is a variable here. We will do A minus xi. Okay. Then finding the determinant of that matrix that is equating to 0, which is called the characteristic equation. And the roots of characteristic equation are called eigenvalues. Okay. So, if A is a n by n square matrix, we will find the determinant of A minus xi equal to 0. This will be a polynomial of order, equation, a polynomial equation of order n. Okay. So, we will have at most n eigenvalues. The solution of that equation will have possible n roots. So that n roots are called the eigenvalues. And Cayley-Hamilton theorem. Okay, this theorem states that if we have a, like we are starting with the a square matrix A, and we will find the determinant of A minus X equal to 0. Here we will get a polynomial equation in the variable X of degree N. Okay, and what they are saying is, in place of X, if we are giving the value A, it will satisfy this equation. That means if we are giving A, we will get this will be equal to 0 matrix. So, for example, okay, kind of example, maybe we will come later. So, did you understand what this actually means? Cayley-Hamilton theorem. The only thing it says is we have a polynomial here. Okay, in the polynomial is in the variable x. In place of x, we are giving the matrix A. Okay, if it is the polynomial x power n plus some a n minus 1, x power n minus 1 plus etc. In place of x, we will give A. So we will get a matrix equation, a power n plus some a n minus 1, a power n minus 1 plus etc. So if we are solving that, we will get it will be equal to the 0 matrix. Here 0 is the real number 0. But in that case, that 0 will be the 0 matrix. That is what Cayley-Hamilton theorem says. Now, let's see two more results. So we already seen what is eigenvalue. If we are taking the product of eigenvalue, we will get the determinant of the matrix A. And trace of A is the sum of eigenvalues. Okay, if we are adding all the eigenvalues, we will get the trace of the matrix A. And if we are multiplying all the eigenvalue, we will get the determinant of A. Do you know what is trace of A? What is trace of a matrix A?
Sum of the diagonal entries.
Yes, trace of A is sum of diagonal entries. Now, one more thing here is, if A is singular, there exists 0 is a eigenvalue. Okay, if A is singular, 0 is an eigenvalue. Can anyone say why 0 is an eigenvalue in this case? You can use this result, determinant of A equal to product of eigenvalues. Using this, can you justify this statement? Here
Determinant will be 0.
Yeah, if A is singular, determinant will be 0. That means this LHS is 0. Product of eigenvalues equal to 0 we will get, right? So product of eigenvalues equal to 0 means at least one eigenvalue is 0. So 0 should be an eigenvalue. Okay. Okay, I think let's go to the questions now. So Okay, first we will start with a simple question. The question is to find the rank of the given matrix. Say it is A. Is given 1, 4, 8, 2, 10, 22, 0, 4, 12. So the options are 1, 2, 3, and none of this. So we have already seen different ways to find the rank, like to find the column rank, row rank, or just go by the definition and all. So in this case, let us just go by the first definition. Okay, finding the determinant of the minors and in that way. Okay, so can anyone say, like, okay, first of all, we will start with this is a 3 by 3 matrix. So we will start with the minor of order 3. Okay, here, what is the minor of order 3 here? Means it just means that a matrix that we can take from this such that its order is 3. Okay, here the possible thing we can take from is, okay. See, we can see what is determinant of A. Okay, if we are finding the determinant of A, this A is a matrix of order 3. Okay, so we can say A itself is a minor. Okay, here we will find the 120 minus. Okay, I'm just finding the determinant here.
Determinant is 0, ma'am.
Yeah, okay, you can just go through the calculation. So determinant equal to 0. So can the rank of A is 0? Sorry, 3. Can the rank of A is 3? Okay, rank is 2. Here, rank of A cannot be 3, right? Because determinant is 0. We are taking a 3 by 3 order subsquare matrix. That is A. Here, the determinant of that matrix is 0. Then rank cannot be 3. Okay. Now we will go to the 2 by 2 order matrices. So, what are all the possible things we can take here? We can take some matrix like this. Something like 1, 4, 2, 10. Some matrix like this we can take. Okay. That means we are taking order 2 minors. Or for if you want other matrix, you can take it as 4, 10, 8, 22. Okay. Otherwise, you can take it as 2, 10, 0, 4. Okay. Or you can take it as 10, 4, 22, 12. Other than that also, we have various possibilities. We can take 1, 8, 0, 12. That is also a subsquare matrix. So
these are all not equal to 0. Determinant not equal 0.
Yeah, we need to find the determinant of this matrix. Like at least one of the matrices is having non-zero determinant. Then we can say rank is 2. Okay, first we will take the submatrix 1, 4, 2, 10. 1, 4, 2, 10. So its determinant is 10 minus 8 equal to 2, not equal to 0. So we got a 2 by 2 matrix within A, which is having determinant non-zero. Okay. So rank of A equals 2. So answer B is the correct option. Rank of A equal to 2. Is there any doubt in this question? How to find the rank of a matrix? if in case if you are getting all these 2 by 2 subsquare matrix equal to 0, you need to go to the next stage. You need to take the 1 by 1 matrix. That is 1, 4, 8 like that. 1 by 1 matrix you have to take and check. Okay. That is the, by definition, that is how we are checking the rank. Now, let's go to the next question. If M is given as the matrix 3 minus 2, 4 minus 2, so here the matrix M is given and an equation M square minus lambda M plus 2i equal to 0 is also given. So only thing is we need to find the value of lambda. So it is a very basic like trivial question. Only thing we need to find is find the M square and minus lambda M plus 2i, equate it to 0 and find the value of lambda. So first of all, let's see what is M square. It is 3 minus 2, 4 minus 2, into 3 minus 2, 4 minus 2. Okay, you can just do the calculation. I will write it here. 1 minus 2, 4 minus 4. Okay, this is the M square. I'm just finding the matrix multiplication. So what will be M square minus lambda M plus 2i? Here M square is 1 minus 2, 4 minus 4 plus lambda M. Lambda M means multiplying lambda with each of the entries. 3 lambda minus 2 lambda, 4 lambda minus 2 lambda plus 2i. 2i means 2 into identity, respective identity matrix 2, 0, 0, 2. Okay. So what the question says is M square minus lambda M plus 2i equal to 0. So we should equate this side to 0. This is equal 0. Okay. So this is 0 means it is a 0 matrix. 2 by 2, 0 matrix. So we have to equate each of the entries with the 0. So what we will get is sorry, the question is M square minus lambda M. Okay. So we will get 3 minus 3 lambda equal to 0. The first entry is minus 3 lambda plus 1 plus 2. Okay. So 3 minus 3 lambda. So the next one is minus 2.
Lambda equal to 1, ma'am.
Yeah, lambda equal to 1. So first we will write the every equation. Okay. 3 minus 3 lambda equal to 0. From this itself, we can conclude lambda equal to 1. Okay. But we need to check whether it is true for each of these cases. So the second equation comes as minus 2 lambda, sorry, 2 lambda minus 2. Okay. 2 lambda minus 2 equal to 0. Again, lambda equal to 1. So from the third equation, we can say minus 4 lambda plus 4. 4 minus 4 lambda equal to 0. Again, lambda equal to 1. And the fourth equation is minus 4 plus 2 lambda plus 2. Okay. So 2 lambda minus 2 equal to 0. Implies lambda equal to 1. So if we are solving the equation, we are getting the unique value of lambda. Lambda equal to 1 is the answer. Okay. Option A is the answer. Is the question clear? It is just the calculation. Just find the values of all these and substitute and equate to find the value of lambda. Okay. Now the next question. Here, the matrix A, 3 by 3 matrix is given. And it is given that this A satisfies this equation A cube minus A square plus A minus I equal to 0. Okay. So, the question is to find what is A power 4. So, how can we approach this question? So, we have terms until A cube only. We need to find what is A power 4. Any idea how to start using
We
this?
can multiply that equation with A.
Yes, correct. We can multiply this equation with A. So it is given that A cube minus A square plus A minus I equal to 0. Okay. So multiplying with A means A into A cube minus A square plus A minus I equals A into 0, which is 0. Okay. Any matrix multiplying with 0 is 0. So here in this side, we will get A power 4 minus A cube plus A square minus A, which is equal to 0. Now, we need to find the value of A square. So, keeping A square this side, we can take all other terms to outside. A cube minus A square plus A. Now, what is A cube minus A square plus A?
It's I.
It is I. Because from this equation, we can say A cube minus A square plus A equals I. So, which is equal to I. So, the value of A power 4 is I. Answer B. Okay. Is this fine?
Yes, ma'am.
Okay. Now the question is, so given matrix is order 5 and it is given, it is a singular matrix. So the question is, what is the maximum possible rank of the matrix? That is, the rank of the matrix can be at most what?
4.
Yes, 4. Because it is given, it is a singular matrix. So determinant of that matrix is 0. So obviously, 5 cannot be the rank. Okay. So, but 4 can be a rank. Maybe can be or cannot be. So the maximum possibility is 4. It can be 5. So, answers. Answer C. 4. Okay. Because determinant of A equal to 0 implies rank of A cannot be 5. It should be strictly less than 5. Okay. Is this clear for everyone? If anyone is having doubt, please ask in between. Okay, let's go to the next question. So given two matrices A and B. So we need to check which of the given statement is true. So the first statement is rank of AB equal to rank of B transpose A transpose. And next statement is rank of AB equals rank of A transpose B transpose. And the third statement is rank of AB not equal to rank of B transpose A transpose. Okay. So we need to check which one is correct among these three options. Anyone knows the answer? Okay, first of all, what about B? Can B be true? Like, first of all, is this valid to write like this? Okay. Okay. Let me ask one question. If M is a matrix, rank of M equal to rank of M transpose. Do you know this result? Rank of M and rank of M transpose are equal. Okay, someone is saying option A is correct. Okay, it is the correct answer. Just because for any matrix M, rank of M and rank of M transpose will be equal. Okay. So, before going to that, let me come to the B. Now, given A and B are any matrix. Okay. I am taking A is 2 by 3 matrix. B is 3 by 4 matrix. Okay. Now, AB is well defined. And what will be AB? AB will be a 2 by 4 matrix. Now, what is B transpose A transpose? So, here in the second option, they are coming with a, sorry, not B transpose, A transpose. A transpose, B transpose. In the second option, they are coming with A transpose, B transpose, right? Here, A is a 2 by 3 matrix and B is a 3 by 4 matrix. So, A transpose is a 3 by 2 matrix and B transpose is a 4 by 3 matrix. Now, is this A transpose, B transpose is well defined? Is this possible?
No.
No. It is not defined. Okay. So, this B is actually kind of invalid statement. Like if AB is defined, A transpose, B transpose need not be even defined. So this case will never happen. So B is always false. Okay. So now we are remaining with only two options. Rank of AB equals rank of B transpose A transpose, or rank of AB not equal to rank of B transpose A transpose. So for that, we will prove the result. Rank of M equals rank of M transpose. For any matrix M, the rank of the matrix and rank of its transpose are equal. Okay. Let us see what is rank of M. We have already seen the result. Rank of M is same as row rank of M. Okay. What is the row rank of M? Row rank of M is the dimension of row space. That means we will find the linear combination of the space generated by the linear combination or the rows of the M. Okay. Now, the row space of M means the space generated by the rows of M. It is same as the space generated by the columns of M transpose, because columns of M transpose is nothing but the rows of M. Okay. So, columns of M transpose. We know columns of M transpose and rows of column space. Column space of M transpose. We know that column space of M transpose is same as row space of M. Is this statement clear? The last statement? Is there any doubt in this statement? Why these two are equal?
No.
Okay. So, this is the dimension of column space of M transpose means column rank of M transpose. Okay. We know for any matrix, column rank, row rank, everything is equal. So column rank of M transpose, we can write it as rank of M transpose. So what we are starting is with the rank of M, and we finally prove that it is equal to rank of M transpose. Clear? So for any matrix, rank of M and rank of M transpose are equal. So here, rank of AB should be equals rank of AB transpose. What is AB transpose? How can we write it as?
B transpose, A transpose.
Yes, AB transpose is B transpose, A transpose. So this is our first statement. Rank of AB equals rank of B transpose, A transpose. Okay. So the statement A is corrected. A is the correct option. Fine. Any doubt in this question?
No, ma'am.
Okay. Now let's go to the this question is just the general question. I have already stated in the beginning. So let me. So here it is given Ax equal to B, a system of linear equation. And it has a unique solution in which of the case? A is given as the n by n matrix and A bar is the augmented matrix AB. Okay, A adjoining B to the side of A. Okay. So in which case Ax equal to B has a unique solution? This we have already stated in the B. So option B is the correct answer. In this case, it will have a unique solution. We have already seen in the class. So let us just go through the other options also. So in the case of A, if rank of A equal to rank of A bar is strictly less than n, what will happen? Will there exist a solution? In the case A, does there exist a solution? Yes, right. If the matrix A and augmented matrix have same rank, always the solution existed. If it is strictly equals the number of variables, here n by n means n is the number of variables or number of columns, we can say. So if it is equals n, then we will say it is unique solution. If it is less than n, we will be having infinite solution. So in the case of A, we will have infinitely many solutions. And in the second case, as we already told, it is unique solution. And what about third option? Is third option is possible? Rank of A bar greater than n. Is this possible?
No.
No. Because A is maximum possible rank is n. Okay, it is an n by n matrix. And A bar will be an n by n plus 1 matrix. Okay, so its rank can be at most n. Greater than n is not possible. So the case C is not at all possible. And what about D? Does there exist a solution? No, right? Rank of A and rank of A bar equal. That case only solution exists. In the case of D, no solution exists. Okay. Any doubt in this question? Let's go to the next problem. So if you understood the concept of rank, you can very quickly say the answer of this question. The question is to find the value of this K such that the rank of this matrix is 1. So the options are given 8, 16, 12 and 9. Can anyone say what will be the value of K?
12, ma'am. 12.
Value of K? No, I want the options are given 8, 16, 12, 9, not 1.
12, 12. 1, 2. Option C.
Yeah, option C, 12. Okay. So option C is the correct answer. This is just by examining we can see. Here, the second row is just a multiple of the first row. Just multiplying with the 2. We will get the second row. Okay. So rank should be what means only like after some elementary operation, row elementary operation, the only one row should exist as non-zero row. All others should be 0 rows. Okay. if k equal to 12, then we can say this third row is a multiple of the first row. Okay, or we can say this is the sum of these two rows. Okay, 1 plus 2 is 3, 2 plus 4 is 6, like that. Okay, so in that case, we can, after elementary operation, we will get only first row remains. Let me just write very quickly. Two, 4, 6, 8. So what I will do for this matrix is, I will do the elementary operations. So R2 will changes to R2 minus 2 times R1, and R3 will change to R3 minus 3 times R1. Okay, so why I am doing this is, I need to keep the 1 here and all other entries I will try to make 0. For that, 2 minus 2 times I should do. That is why I am taking R2 minus 2 R1. Here also 3 minus 3 times 1. For that, I am taking R3 minus 3 R1. So R2 minus 2 R1, here everywhere I will get 0. And R3 minus 3 R1, 3 minus 3, 6 minus 6, 9 minus 9, and K minus 3 into 4. Okay, so in order for this, this rank of this matrix and rank of this matrix are same because they are equivalent. They obtained using the elementary operation. So rank of this matrix is should be 1. Okay, that is the question. Rank should be 1 means it should be equal to 0. If it is non-zero, then rank will be 2 because 2 non-zero rows are there. So rank equal to 1 implies that k minus 3 into 4 equal to 0. That implies k equal to 3 into 4, which is equals to 12. Okay, so option C is the correct answer. It should be 12. Just by examining, you can say it is 12. Otherwise, you can just do step by step to obtain the value equal to 12. Okay. If anyone is having doubt, please ask in between. Now the next question is, so it is given a system of equation. So we need to find whether it has unique solution or infinitely many solution or no solution. So the options are no solution, unique solution, infinite solution, finite but more than one solution. So how we will start? Like here we have got a system of 3 equations in 3 variables x, y, and z. So how we will proceed? How we will write it as a matrix? First, we need to write it as a matrix equation, like A, x equal to B. Then we will find the rank of A and the rank of A, B. Then we will go to the earlier condition, whether rank of A equal to rank of A, B, and so on. So, okay. So, how can we write it in a matrix form, this equation, system of equation?
1, 2, minus 3,
Yes.
minus
Okay, 1, okay, this is minus Z.
okay, minus 1 then.
Okay.
Sorry.
So the first equation is x plus 2y minus Z. Okay. So we will take the coefficient of each of the variable and write it as the,
Write it in row.
okay, good. 1, 2, minus 1. Okay. So what we are doing is multiplying this with the x, y, z. Okay. So if we are writing like this, what we will get? 1x plus 2y minus z. That is the x plus 2y minus z. And it should be equals to 10. That is what this equation says, right? It is equal to 10. So now again we will write the second equation like this. So what is the second row here?
Minus 1, 1, 2.
Minus 1, 1, 2. And what will be in this side?
Here is 2 ma.
Yes, 2. So again, the second row gives the second equation. Minus x plus y plus 2z equals 2. And the third row is?
2, 1, minus 3.
Okay, 2, 1, minus 3. And here it is 2.
2.
Okay. So we have written this equation in the matrix form. Say Ax equals B. Now we can go to the previous conditions like rank of A and rank of AB and how it is related and all. Okay. So we will see the matrix AB, augmented matrix. How we will write the augmented matrix? 1, 2, minus 1, minus 1, 1, 2, 2, 1, minus 3. First, we will write the matrix A itself like this. Just draw kind of 10, 2, 2. Okay. Actually, if you want, you can find the rank of A and the rank of AB separately. But just in one step, we can find both the rank of A and the rank of AB like this. Okay, just adjoin these two here. Now, to find the rank of A, we will go to the row operations. So this is 1, 2, minus 1, 10. So I will add this R2 plus R1 to make this as 0. So I will change R2 to R2 plus R1. So minus 1 plus 1, 1 plus 2, 1. And here it is 12. And what should I do in the R3, third row? I need to make this as 0.
We can multiply the first row into 2, then we can subtract.
Yeah. So I will suggest you to do directly with this first one. Means here I can do 2 minus 2 times the first row, right? So this is the standard way of doing. Like anything is fine. But if we are making this 0 in this first column, just take that element and find what is the element here. Multiply with the corresponding factor and subtract that row. Okay. So I'm doing here R3 minus 2R1. So 2 minus 2 I will get. And 1 minus 4. Minus 3. And minus 3 minus 2 times. Minus 1, right? Fine. So this is what I am getting by R3 minus 2R1. Now our next aim is the first row we will keep like that. Second row also we will keep like that. If you want, you can make the coefficient of this second P2 entry as 1. But here it is minus 3 and 3. So we can just start this minus 3 and 3 to obtain it as 0. Okay. 1, 2, minus 1, 10. 0, 3, 1, 12. And 0 plus 0 is 0. What I am doing is R3 changing to R3 plus R2. So whatever the operation here I am doing is, now I am taking with respect to R2. Okay, 0, 0, minus 6. Now, what is rank? What is rank of A here?
2, ma'am.
2. And what is rank of AB?
3.
Rank of AB is 3. So what about the solution?
No solution.
Yes,
That is it. Oh, okay.
there does not exist a solution because rank of A and rank of AB are different. They are not equal. So there does not exist a solution for the given system. Okay. Any doubt in this question?
No, ma'am.
Okay. So let's move to the next problem. Here it is given A and B are two square matrices and both are of order 7. Okay, and given A is non-singular. That means A is invertible. And given the rank of B is 3. Now the question is, what is rank of AB? So to find the rank of AB, to find the upper bound of rank of AB, we have one result. What is that?
Rank of AB less than or equal to minimum of rank of A, rank of B.
Yes, minimum of rank of A, rank of B. So here, what is rank of A and rank of B?
Rank of A is 7, rank of B is 3.
So what is this value, minimum of rank of A, rank of B? It is 3, right? Minimum of rank of A is 7 and rank of B is 3. It is given. Since A is non-singular, rank of A is 7 and rank of B is given as 3. So minimum of rank of A, rank of B is 3. So the first thing we got, rank of AB should be less than or equal to 3. Okay. So from here itself, actually, you can conclude option C is the correct answer because all other options are strictly greater than 3. But actually, we can prove that this rank of AB is equal to 3. It is not just less than or equal to 3. It is equal to 3. It is not 2. It is not 1. Okay. How we can prove? Now, what we want to find is, okay, since A is invertible, I can write it as okay. Here B means identity into B. Instead of identity, I am writing it as A inverse A. Since A is invertible, A inverse exists. So I can write like this. Okay. Again, I am doing this as minimum of rank of A inverse. So A inverse AB means A inverse into AB. So I can write it as rank of A inverse and rank of AB. Okay. So this is minimum of rank of A inverse and rank of AB. We don't know the value. See, what does this means? Rank of B is less than or equal to rank of A inverse, and rank of B is less than or equal to rank of AB. Correct? This both condition we will get. And what is rank of B? It is 3. 3 is less than or equal to rank of AB. Now, coming to the equation 1 and 2, what can we conclude? Here, 3 less than or equal to rank of AB, and this rank of AB is less than or equal to 3. Less than or equal to rank of AB, which is less than or equal to 3. This implies rank AB equal to 3. Correct? Rank of AB is bounded below and above by 3 means only possibility is it is 3. Is this okay? Any doubt in this question?
No, ma'am.
Okay. Now, okay, the matrix is given as 1, 1, 2, 0, 1, 0, 2, x, y. And we need to find the value of x and y such that rank of this matrix is 2. So what we will do? We will just find the reduced form, equivalent form of this matrix. So here it is 1, 1, 2, 0, 1, 0, 2, x, y. So here 1, 1, 2, 0, 1, 0. So I'm just reducing this like the third row. I will write it as R3 minus 2 R1. That means 2 minus 2 times 1. Okay. Here 2 minus 2 times 1 equal to 0. And the x minus 2 and y minus 2 times 2, 4. Okay. So what should be the value of x and y here for the matrix as rank 2?
X equal to Y equal 4 mark.
Yes. So x equal to 2 and y equal to 4. If this condition is satisfied, obviously rank will be 2 because 1, 1, 2, 0, 1, 0. Only 2 non-zero rows are there. Okay. Like also they are not dependent. So the rank will be 2 if x equal to 2 and y equal to 4 because this is going to be the 0 row in that case. Fine. Any doubt? Anyone?
No, ma'am.
Next question is so given A is an n by n invertible matrix and the two statements are given. So we need to check which one is true. Okay. So the first statement is the homogeneous system Ax equal to 0 has a trivial solution. Homogeneous means here this side it is 0, right? That is what homogeneous means. And it has a non-trivial solution, first statement. And second statement is Ax equal to y has a solution x for each n by 1 matrix y. So which one is true? Can anyone say? Given A is an n by n invertible matrix. Is A true? What they are saying is it has a non-trivial solution. What is the trivial solution? What does it mean by trivial solution? Yeah, B is true and A is false. Okay. Okay. What is the meaning of trivial solution? Trivial solution means the zero solution. Here you can see Ax equal to 0. If x I am taking as the 0 column matrix, whatever the A here, Ax equal to 0, it will be. Correct? Since x equal to 0. So that x equal to 0, like for any homogeneous system, this x equal to 0, the trivial solution will exist. So here the question is, does there exist a non-trivial solution? Means a non-zero solution exists or not? We can check. Given Ax equal to 0. Okay. And we are supposing that x is any solution. I don't know what is x, whether it is the 0, that is whether it is trivial value or a non-trivial solution. I am assuming x is a solution. Since A is invertible, it is given A is a n by n invertible matrix, right? So since A is invertible, what we can do? We can use the use of A inverse. That means I am multiplying with the A inverse on both sides. So A inverse Ax equal to A inverse into 0. Okay, I am multiplying A inverse on both sides of this equation. So what I will get is x equal to 0. A inverse A is identity, so x equal to 0. So whatever the solution I am assuming, I am getting x is the trivial solution. So only trivial solution exists. So A is false. Now, what about the B? The system Ax equal to y has a solution x for each n by 1 matrix y. Like whatever the y we are taking, there exists a solution x. That is what the statement says. So someone told B is the correct answer. So if B is the correct answer, we should prove the existence of that solution. Okay, so what will be the solution? One more thing, in the earlier case, I told x equal to 0 is always a solution for any matrix. Whether A is singular or non-singular, x equal to 0 will be a solution. But in this case, x equal to 0 need not be a solution. Because if I am taking x equal to 0 here, this LHS will be 0. And in case y is a non-zero vector, then 0 equal to some non-zero value. It is not possible, right? So in this case, x equal to 0 need not be a solution. But in homogeneous case, always the trivial solution existed. Okay. Now coming to the question, given Ax equal to y, and it states that it has a solution x. So my question is, what is the solution x? What value of x will give Ax equal to y? Again, use the fact A is invertible. Something similar we have already done actually. Or you
Madam,
can,
when y is non-zero, then the statement B is correct.
When y is not, when y equal to 0, then what is the problem?
It get a trivial solution.
Yeah, the question is, it has a solution x. Like they are not
Okay.
considering trivial
Correct, ma'am.
solution.
B option B is correct.
Yeah, if y equal to 0, x is the 0 solution, we can say. If y is
Okay.
non-zero, what can be the value of x?
X is A inverse into Y.
Yes, A inverse into y.
Y.
Yeah, correct. So, here we have Ax equal to y and given A is invertible. Okay, so we can multiply with the A inverse on both sides. A inverse Ax equal to y implies x equal A inverse y implies x equal to A inverse y is the required solution. So option B is true. Is this okay for everyone? Any doubt in this question?
No, ma'am.
Okay, so let's go to the next problem. Okay, a matrix, a square matrix is given. So let's call it as A. Okay, we need to find the characteristic polynomial and eigenvalues of the matrix. Okay, what is the procedure?
In diagonal, we should subtract lambda.
Yeah, the equation is determinant of A minus lambda I. Like lambda is any variable, you can take either lambda I or xi or something. Okay, it should be equal to 0. Okay, so whatever we are getting from this, like we will do determinant of A minus lambda equal to 0. So that is the characteristic equation, not polynomial. That will be the characteristic equation. So here we will get 3 minus lambda, 1 minus 1, 2. So I'm just writing directly the A minus lambda I. The thing is A minus lambda times the identity matrix. So only along the diagonal, we need to subtract the lambda. 2 minus lambda minus 1, 2, 2, 0 minus lambda. So it should be equal to 0. Okay. So let's, this is just calculation. We need to find the determinant. 3 minus lambda into minus lambda plus 2 okay. So the remaining is just a calculation. So you need to like just multiply everything and just simplify it. So it is a 3 by 3 matrix. So what we will get is a order 3 equation. Okay, order 3 polynomial. Okay, all the calculation I am not writing. I am just writing the what is the equation we are getting. I hope you can do. So minus lambda cube plus 5 lambda square minus 8 lambda plus 4 equal to 0. Okay. So this is after simplifying this, this is the equation we are getting. So you can just cross check it once. Okay. So whatever we are obtaining here is the characteristic equation. Okay. Equation means there is some equality sign. Here some equality sign is there. Okay. This is equal to 0. If we are equating this to 0, we will say it is a characteristic equation. And what is characteristic polynomial? The characteristic polynomial is minus 1 power. So characteristic polynomial should be a polynomial. It should not be equal to some 0 or something. Okay. So we will write it in terms of some p of x. It is a function. Okay. Or p of lambda. I can write p of lambda equal to minus 1 power 3. If it is an n by n matrix, we will write it as minus 1 power n. Here it is a 3 by 3 matrix. So minus 1 power 3 into determinant of a minus lambda I. Okay. So this is the characteristic polynomial. If we are equating this to 0, then it is the characteristic equation. So if you are asked to find the polynomial, this is what you should write it. So the characteristic polynomial, here it is. P of lambda equal to minus 1 power 3 is minus 1. And the determinant of a minus lambda I we have already found here. This is determinant of a minus lambda I. So we are multiplying that with minus 1. So the polynomial will always, like why we are taking minus 1 power n is, always we need the leading coefficient as 1 plus 1. Okay. To avoid that minus, we are taking minus 1 power n. Okay. So we will get lambda cube minus 5 lambda square plus 8 lambda minus 4 equal to 0. Okay. This is our characteristic polynomial. Okay. Now we need to solve this equation. Sorry. Here it should not be equal to 0. Okay. Now, what are all the eigenvalues? Eigenvalues mean solution of the characteristic equation, or we can say roots of the characteristic polynomial. So the polynomial here we obtained. If we are finding the roots means the value of lambda at which it becomes 0. So roots of characteristic polynomial is the eigenvalue, or we can say it is the solution of characteristic equation. So this is the equation. So if we are finding the solution means what are all the lambda which satisfy this equation. Okay. So both are same. So we need to find the eigenvalues here. So can anyone say what are all the eigenvalues here?
1, 2, 3.
Yeah. 1, 2, correct. So just by examining 1, we can say 1 minus 5 plus 8 minus 4. It will be 0. So 1 is a root. So usual division, you can like lambda cube minus 5 lambda square plus 8 lambda minus 4 divided by lambda minus 1. you will get a equation in second degree polynomial. So from second degree polynomial, you can extract what are all the roots. So roots of p lambda are 1, 2, 2. So eigenvalues are 1 and 2. 2 is repeated 2 times and 1 times. Values are 1 and 2. Clear? Any doubt in this question?
No, ma'am.
Okay. So let's go to the next problem. Given a matrix A, so the matrix A, 3 by 3 matrix is given. So the question is the possible values of y1, y2, y3. You can see it as a column y1, y2, y3, such that the system Ax equal to y has a solution. Okay, is that question clear? What I will write is A 3 minus 1, 2, 2, 1, 1, 1 minus 3, 0. Sum x1, x2, x3 equals y1, y2. Okay, if I am writing it like A x equal to some y, and the question is for which tuple y1, y2, y3, I can say this has a solution, like the solution x exists. Okay, so how can we do this? If solution exists, what we want? Like, what is the relation between rank A and the rank of augmented matrix AY?
Rank of A equal to rank of augmented matrix equal to
Yes, rank of A and rank of AY should be equals if a solution exists. It can be unique or non-unique depending on whether it is equal to 3 or less than 3. Okay, just leave that case. The thing is, just we are asking about the existence, not about the uniqueness and all. Okay, so rank of A and the rank of AY should be equals. Okay, so let's just see. Here y is some kind of unknown. If we are doing lots of operations here, it will be complicated. So first we will see what is rank of A. Okay, can anyone say what is rank of A? We can use any of the method.
2,
Okay?
ma'am.
Which, sorry, can you repeat?
Rank of A is 2.
Sure. Okay, let me check determinant of A. So what is determinant of A? 3 times 3, right? This one. It is not equal to 0, right? Correct? Is this fine? We have found the determinant of A and we are getting it is non-zero. Okay?
Yes, ma'am.
Okay, so what is rank of A?
So it's 3.
Yeah, rank of A will be 3. So, rank of A equal to 3. Now, can you say what is rank of AY?
It's also 3.
Yes, rank of AY is also 3 because AY means we are just concatenating this to here. Okay, so whatever the operation we are doing, like we can see we are doing some row operation or something. So here we will get 3 non-zero independent rows. Okay, so here one more term, whatever it is, 0, non-zero or whatever, we can say again rank of AY is also 3. Okay, 3 rows are there. So rank of A and rank of AY equal to 3. This is true for any Y. For any Y, rank A equal to rank of AY. Okay, so our question was to find the tuple Y1, Y2, Y3 for the system AX equal to Y has a solution. So our answer is any Y. For any Y, the solution exists. So let's do one more question. So the last question is, A is given a matrix. Three by three order. Okay. So given A is a 3 by 3 matrix and the eigenvalues are given 1, -4 and 5. So what is the trace of A?
Sum of the eigenvalues.
Yeah, trace of A is sum of eigenvalues. And here the eigenvalues are given as 1, -4 and 5. Okay, which is equal to 2. Okay, so option D is the correct answer. Now, what is the determinant of A?
Product of the eigenvalues.
Yes. It is -20, right? Product of the eigenvalues 1 into -4 into 5. Now let me ask one question. Is A invertible? Okay, yeah, now you can say directly. Is A invertible?
Yes, ma'am.
Yes, obviously it is invertible.
Determinant is non-zero.
The determinant is non-zero. So what I want to say is here 0 is not an eigenvalue. So obviously it will be invertible. So that is what I want to say as we have already seen the determinant. Fine. Okay, now Let me ask one more question. If A is a, again I am taking A is a 4 by 4. Singular matrix with the eigenvalue. Again, the same eigenvalues 1, -4, and 5. Then, what is trace of M? Here, I am taking 4 by 4 matrix and it is singular, and some eigenvalues like 3, 1, -4, 5 are eigenvalues.
2, ma'am.
Yeah, again it is 2.
Because one eigenvalue is 0.
Yes, yes, correct. Matrix, and given that 1, -4. Okay, I'm not saying this 1, -4, 5 are not just the eigenvalue. This 1, -4, 5 are eigenvalues. So since A is a singular matrix, we know other than this 3, we have one more eigenvalue because it is a 4 by 4 matrix and it is singular. So that fourth eigenvalue should be the 0. So trace of A should be 1 plus -4 plus 5 plus 0. Okay, again it is 2. And clearly, what is determinant of M? It is 0. Obviously, it is given singular. Otherwise, also product of eigenvalue, it is 0. Okay. So, okay, I think let's stop the session today. So if you have any doubt, you can ask. Otherwise, we can stop the session. Any doubt in this question or the previous any of the question? Okay. So, okay, then let's stop the session. Yeah, thank you all for attending. So the next week, it is the last week, week 8. So we will meet in the same time for the next week session. So let's stop for today.
Thank you, ma'am.
Yeah, thank you all.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.